Okay, today is the last type of graphing polynomials, and this is a special case. And before we do this, we want to talk about perfect squares. Um, so we're going to fill this in here. Remember, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. And let's keep going. 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. So same idea here, x squared, we could simplify. 2x squared is the same as 4x squared, because we're going to square both parts. The quantity 3x squared is the same as 9x squared. 4x squared is the same as 16x squared, and then 25x squared. Okay, we can split this up as well. So the quantity 6x squared, quantity 7x squared, quantity 8x squared, quantity 9x squared, and quantity 10x squared. Okay, so we're going to use those perfect squares. So go ahead and hit pause and write them down because I know I went through them quickly. And then when you're ready, hit play again. Okay, factoring a difference of two squares. So far we've done GCF, which you always check for first. We've done grouping, which only happens when there's 4 terms. We've done AC split, which happens when there's 3 terms. Now, if we look at this, we're going to notice that there's only 2 terms here. So we can't use any of those methods except for GCF. But there's a special case here. Notice I can take the square root of 16. So the square root of 16 is 4, and the square root of x squared is x. The square root of 25 is 5. So what I'm going to do, and you'll think about this if you think back to multiplying, is I'm going to write it twice because it was squared, but instead of having the same side, we have opposite sides. You can write those in either order, it doesn't matter. So for the next one, the square root of 64 is 8, square root of k squared is k, square root of 25 is 5. So we're going to write that twice and make 1 plus and 1 minus. Okay, for this one, the square root of m squared is just m. The square root of 49 is 7. So 1's plus and 1's minus. I'm going to do, well, I'll do a couple more. The next one, same idea, square root of a squared is a, square root of 36 is 6, square root of b squared is b. So it doesn't matter that there's 2 variables in there, we can still take the square root. 1's plus and 1's minus. The reason I want to do more than 1 on here is because I can actually divide everything by 3. So I can divide by 3 to get 9 times y squared minus 4. Now the square root of 9 is 3. The square root of 4 is 2. So if we write that twice, since it was squared, and make 1 plus and 1 minus, this is our factored form. Okay, last one, try it on your own. If you have any questions, let us know. If not, go ahead and work on the practice, and then we'll move on to our 3.0, which is choosing methods. Have a great day.